Assalamu alaikum. This is once again Bilal sir for you and welcome to Bilal sir School of Mathematics. Today we are going to solve some questions from chapter number 1. So let's start. Question number 1 says that express each number as a product of its prime factors. Express each number as a product of its prime factors. This is question number 1, part first. Part first is we have to express this as a product of its prime factors. So we can solve it by either division method or tree method. So let's see, we will use both methods here. It is 140, it is 270, and for 70 we can use 2 into 35, and for 35 we can have 5 sevens are 35, and by division method we can use like this. It is same 140, it is 2 into 70, it is 2 into 35, it is 5 into 7. So the prime factors of 140 are 2 cross 2 cross 5 cross 7. These are the prime factors. Prime factors of 140 are 2, 2, 5 and 7. This is how we find the prime factors of any composite number. Now, there are 4 more parts for this question, and you will try yourselves. If you will have some problem, then you can mention in the comment box. Bilal sir is always with you. Now let's take question number 2. Find the LCM and HCF of the following pairs of integers. We have to find the LCM and HCF, and then we have to verify whether LCM into HCF is equal to product of the numbers. Let's take question number 2, part first. It is 26 and 91. 26 and 91. We have to find the LCM and HCF. LCM and HCF. So we have 26 is equal to, we know that 26, 2 into 13 and 13 into 1. 26 can be written as 2 into 13. And also we can write it as this. And 91 can be written as 7 into 13 and 13 into 1. 91 can be written as 7 into 13 into 1. Therefore, LCM of 26, 91 is equal to LCM, least or lowest common multiple, that is 2 into 7 into 13. From these two, We know that LCM is the product of the highest powers of prime factors. Highest powers of prime factor, that is 2 power 1, 7 power 1, 13 power 1. And it is 2 into 7, that is 14 into 13, that will be 182. That will be 182. And also HCF. HCF will be, what is HCF? HCF is common factor, so there is only one common factor, that is 13, and also it will be the highest common factor. It is 13. What is now? We have to verify HCF 26,91. We have to verify whether HCF cross LCM is equal to product of numbers. Product of numbers. What is HCF? HCF is 13. What is LCM? It is 182. And what is the product of numbers? It is 26 into 91. Which implies if you will find this product and this product, you will come into know that 13 into 182, it is 2366, and also 26 into 91, it is also 2366. This shows that for these two numbers, this HCF into LCM is equal to product of numbers, that is LHS is equal to RHS. So this has been verified for these two numbers. You can also try it for the other two parts. It is 510 and 92, 336 and 54. Let's take now question number 3. If there is any problem in understanding, you can also mention in the comment box. Now question number 3. It is find the LCM and HCF of the following integers by applying the prime factorization method. It is question number 3, part first. It is 12, 15 and 21. 12, 15 and 21. We have to find LCM and HCF by applying the prime factorization method. We have 12. 12 can be written as 2, 3 into 2, or we can write it as 2 cross 2 cross 3, because 12, it is 2, 6 and 2, 3. Also 15 can be written as 3, 5. And also 21 can be written as 3 into 7. So we can write it as, you can also mention 1 here, 5 1s are, 7 1s are, or 3 1s are. Since we are taking the prime factorization, so 1 is not a prime number. The smallest prime is 2, so we can omit this step. We can omit the last step. We can write it as 2 cross 2 cross 3. And 15, it can be written as 3 into 5. And 21 can be written as 3 into 7. Now, what will be the LCM? LCM will be equal to the product of the highest powers of prime factors. Product of the highest powers of prime factors. See, these three this is common, and it will be the also the HCF. This will be the HCF, but to find the LCM, it will be 2 cross 2 cross. From these three threes, we will take only one. It is 5 into 7. So this will be 2 twos are 4, 3s are 12, 5s are 60, and it will be 420. LCM will be 420. And HCF will be simply, it is common factor is only 3. It is the HCF is the Shabash, I have told you in previous lectures, it is the product of the prime factors of the product of the smallest powers of the prime factors. It is 3, and HCF is 3. By this way, we can find the LCM and HCF of 3 numbers. LCM and HCF of 3 numbers. Now we will take another important question. It is important from the examination point of view. It is question number 4. Given that, it is given, we have HCF of 306, 657 is equal to, it is 9. It is given. Given that HCF of 306 and 657 is 9, we have to find the LCM. Since we know हम जानते हैं कि what we have read in previous lecture, that LCM of two numbers into HCF of two numbers is equal to product of the numbers. So we can use it here. So LCM of 306, 657 into HCF of 306, 657 is equal to 306 into 657. Now, it is given that HCF is 9. So this implies LCM of 306, 657 into 9 is equal to 306 into 657, which implies LCM of 306, 657 is equal to 306 into 657 over 9. So now, after calculating this, we can easily find the LCM. Now see, it is 9, 9 ones are 9, and it is 9 threes are 27, and it is 9 fours are. ठीक. So LCM will be 34 into 6, 5, 7. You can easily calculate this product, so that will be the HCF. You have to write the answer in the comment section. What will be the LCM of these two numbers? It is an important question from the exam point of view. Now, there is another important question. There is another important question. It is, check whether 6 raised power n can end with the digit 0 for any natural number n. Sorry. I have got some chest problem. Now we have to check whether this number 6 power n can end with the digit 0 or not. Now see, any number. Let's take any example. Any number that ends with digit 0. See, we have 10. It will be 2 into 5. We have 20, or we have 100. It will be 5 into 20. We have 10,000, or we have 1,000. 1,000 will be 5 into 200. 5 into 200. In general, from this pattern, you will see that one factor will be 5. One factor will be 5. The number which ends with digit 0 has 5 as one of the factors, one of the prime factors. You have to keep in mind that any number, whatever power it has, must have, if it ends with digit 0, must have 5 as it's one of the prime factors. So now we have 6 raised power n is equal to 2 into 3 raised power n. We have 6 raised power n is 2 into 3 raised power n. This gives that this factorization implies that it does not have 5 as it is factor, because we know that any number that ends with digit 0 must have 5 as one of its prime factors. Prime factors. This is not possible in this case. In this case, 5 as one of its prime factors is not possible. So we can say that 6 raised power n cannot end with digit 0. So this number 6 raised power n cannot end with digit 0. Make this clear that any number that ends with digit 0 must have 5 as one of its prime factors. That is not in this case. So 6 raised power n cannot end with the digit 0. Do you get it? Okay. I will again recap this. This factorization implies that it does not have 5 as factor, because we know that any number that ends with digit 0 must have 5 as one of its prime factors. This is not possible in this case. So we can say that 6 raised power n cannot end with digit 0. Now another question is question number 6. Explain why 7 into 11 into 13 plus 13 and these are composite numbers. First we will take this. We have to, it is question number 6. Explain why 7 into 13 7 into 11 into 13, sorry, it is 7 into 11 into 13 plus 13 plus 13. Explain why this is a composite number. We have to show why this is a composite number. अगर आप composite number की definition देखेंगे, composite number, if we will see the definition of a composite number is any number with more than 2 factors. More than 2 factors is known as a composite number. Now, whether this number holds this definition or not. If this number holds this definition, then it is a composite number. If it doesn't hold this definition, so it will not be a composite number. Let's see. This will be equal to, if we will take this 13 out, it can be written as 13 into 7. This 13, take it out, we can write it as 7 into 11. 7 into 11, we have took this 13 out, it will be plus 1. It will be 13 into 7. 11 is 77, it will be 77 plus 1, and it will be 13 into 78 into 1. We can write it as 13 into 78 into 1. So Now you see how many factors it has. How many factors it has? 13 into 78. Now from this we will get 13 into 78. But 13 into 78 can be written as 13 into 78 into 1, because 1 is the factor of every number. So it has how many factors? It has 1, 2 and 3. 1, 2 and 3 factors. That means it holds this definition. So it is a composite number. Since this number has more than 2 factors, more than 2 factors, 2 factors, which implies it is a composite. It is a composite number. Likewise, you can try for another one. If you will have some problem, you can mention it in the comment box. Now another question, the last one. It is question number 7. It is question number 7. There is a circular path around a sports field. Suppose this is a sports field. Sports field. There is a circular path around this. Let this be a circular path around this. Sonia takes 18 minutes to drive one round of the field. Sonia takes 18 minutes. Sonia takes 18 minutes. While Ravi takes 12 minutes. Ravi takes she takes 18 and he takes 12. 12 minutes. Suppose they both start at the same point. Suppose they both start from this point. Starting point. This is the starting point. Suppose they both start at the same point and at the same time and go in the same direction. Suppose they both go in this direction. And go in the same direction. After how many minutes will they meet again at the starting point? Now the question says that after how many minutes they both will meet at starting point. That means, now see this, just imagine they both start from this point. Sonia takes 18 minutes, Ravi takes 12 minutes. After how many minutes they both will meet at the starting point? That means it is just like the converging point. This will be one converging point. After how many minutes they will meet or they will converge at this point? So there will be a number. There will be a number which comes in the table of 12 and 18. Now let's imagine there is a number, there will be a number, because we have to see after how many minutes they will meet again at the starting point. That means they will meet, these two have to meet, but it takes 18 minutes, he takes 12 minutes, so they will meet at a common point. They will meet at a common point. So what will be the common point? And that will be the LCM. It will be the lowest common point. That means the lowest common multiple of 12 and 18. At that point, this point where both them they will meet, it will be the LCM. It will be the LCM of 12 and 18. So to find the number of minutes after which they both meet at the starting point, we find the LCM. We find the LCM. We find the LCM of 18 and 12. We have 12 is equal to 2, 2s are 4, 3s are 12, and 18 is 2, 3s are 6, 3s are 18. So what will be the LCM? It will be, it is 2 cross 2. From these two we will take 1, from this, and from these 3 we will take 1, and this 3 remains, and it is 2 2s are 4, 3s are 12, 12 3s are 36. After 36 minutes, both Ravi and Sonia will meet at the starting point. Hope that you may have, or you will understand them clearly, and try to solve the remaining questions that I have put as a practice work for you. If there is if you will have some problem in understanding, you will write this, or you will mention in the comment box. We will come with another interesting lecture on rational numbers. Till then, have a nice time.